My name is William Hadala, Chief Strategy Officer at American Lithium Energy. What you're about to hear is not a commercial pitch, it's a briefing on what mission ready energy storage actually looks like for the next generation of defense aviation. The U.S. defense enterprise is at an inflection point. Electrified aircraft, directed energy weapons, autonomous systems, all of them converge on one dependency: the battery. Not a commodity battery, a mission ready battery, NDAA compliant, made in the USA, engineered for combat conditions. That's exactly what American Lithium Energy delivers. Let's get into it. ALE is a domestic U.S. manufacturer. We build mission ready battery systems for defense platforms, from electrified vertical lift to autonomous aerial systems, directed energy weapons, and tactical edge power. We're not reselling foreign manufactured cells with a U.S. label on the box. We design, engineer, and manufacture our cells and systems here on American soil under defense aligned quality systems with no foreign dependency risk in our supply chain. Our technology bridges two worlds: the performance demands of commercial electrification innovation and the survivability and certification requirements of military operations. Those two worlds require very different engineering discipline, and American Lithium Energy operates in both. Four mission areas drive our product architecture: electrified vertical lift, autonomous aerial systems, directed energy, and tactical edge. Every cell we build is optimized against one or more of those requirements. And every product we ship is NDAA compliant end to end. Let me frame the strategic context. Electrified propulsion is no longer a research program. It's becoming a core defense capability. JADC2, Future Vertical Lift, Agility Prime. These programs are actively pulling electrification into the operational force. The demand signal is real and it's accelerating. The operational advantages are significant. Silent flight reduces acoustic detection. Lower thermal output defeats infrared tracking. Fewer moving parts compress the logistics tail for forward deployed units. These are not incremental gains, they're survivability multipliers for contested environments. But here's the bottleneck that every program office knows and few vendors address directly. Battery performance has been the limiting factor. Range, endurance, pulse power, thermal management. The platform is only as capable as the energy system underneath it. And the supply chain picture makes this more urgent. Defense platforms cannot depend on foreign manufactured battery cells. That's a compliance risk, a national security risk, and an operational continuity risk. The domestic battery supply base has not kept pace with defense demand. American Lithium Energy is purpose-built to close that gap. There are 5 technical differentiators that define American Lithium Energy's position in the defense battery market. I'll walk you through each one. First, ultra-high energy density. We're targeting 400 plus watt hours per kilogram at the cell level. That directly extends range and endurance for defense eVTOL missions. More energy in the same mass means longer loiter time, greater mission radius, reduced resupply frequency. Second, extreme pulse power. Our high power cells deliver 180 amps continuous and 250 amps on pulse without voltage sag. That matters at takeoff, during transition, and for any peak load event. The platform doesn't get a grace period. The battery has to perform on demand. Third, defense-grade safety. American Lithium Energy's SafeCore architecture is designed to prevent thermal runaway propagation inside the cell, not just at the pack level. Single cell failure containment before it cascades is an engineering discipline, not an afterthought. Fourth, wide temperature operation, Arctic to desert. Reliable performance across that range without extensive thermal conditioning infrastructure reduces program complexity in the field. Fifth, NDAA-compliant supply chain, made in the USA, full stop. That's not a marketing line. It's a compliance requirement for a significant portion of defense acquisition programs, and American Lithium Energy meets it by design. Defense eVTOL missions are unlike commercial air taxi operations. The performance demands are asymmetric. extreme pulse power requirements at certain phases, sustained high-efficiency delivery at others, and non-negotiable reliability at all times. American Lithium Energy designs to the full flight profile, not just the cruise segment. Phase 1 is vertical takeoff and hover. This is the highest stress demand event for the battery. We're talking very high peak power required for liftoff and initial stabilization, with zero tolerance for voltage sag. Phase 2 is transition, the aircraft shifting from vertical lift to forward flight. This requires a second burst of extreme output that most conventional battery chemistries can't sustain after the initial takeoff load. Phase 3 is cruise. Here, the priority shifts to sustained energy delivery and efficiency, maximizing range and endurance without the battery becoming the limiting factor on mission duration. Phase 4 is landing and emergency reserve. SafeCore protection and reliable reserve power ensure that recovery is safe even under degraded conditions. This four-phase architecture is baked into our cell design and system engineering. We're not forcing a commercial energy product into a defense flight profile. We're building the power system the mission actually demands. American Lithium Energy's cell portfolio spans 3 technology tiers, each optimized for a different portion of the mission envelope. The first tier is our high-power lithium-ion cells. These deliver 180 amps continuous and 250 amps on pulse. They're the right tool for vertical lift, transition bursts, and directed energy pulse systems, any application where instantaneous power delivery is the critical variable. The second tier is our high-energy aerospace cells, approximately 350 watt-hours per kilogram. These are optimized for cruise endurance, ISR missions, and long-duration loiter operations. When range and time on station are the mission objectives, this is your cell architecture. The third tier is our next-generation high-energy platform targeting 400-plus watt-hours per kilogram. That performance level enables long-range eVTOL, hybrid electric aircraft, and persistent surveillance platforms that are pushing the boundaries of what electrification can support today. For systems integrators and program offices, this breadth of product options means you don't have to engineer around a capability gap in American Lithium Energy's portfolio. We have the right cell for each phase of the mission, and we can support multiple tiers within a single program. Safety in a defense battery system is not a feature, it's a system requirement. American Lithium Energy engineers it into the cell architecture from the ground up. Abuse tolerance is validated against crush, shock, vibration, overcharge, and external short-circuit conditions. These aren't lab scenarios. They're the mechanical and electrical stresses a battery will encounter in contested operational environments. Thermal runaway prevention is where SafeCore architecture becomes critical. If a single cell fails, SafeCore contains that failure before it can propagate into a pack-level event. That's the difference between a manageable anomaly and a catastrophic mission failure. Combat survivability means the battery is engineered for extreme mechanical, thermal, and electrical stress. A platform that operates in contested airspace cannot carry an energy system that degrades under the exact conditions the mission demands. And finally, certification. American Lithium Energy supports MIL STD 810, DO 3111A, UL, and aerospace certification pathways with full test documentation. For program offices working through a certification pipeline, American Lithium Energy is not a vendor that hands you a cell and walks away. We support the certification process as a partner. American Lithium Energy is not a cell supplier. That distinction matters enormously to program managers who have dealt with the integration complexity of stitching together cells from one vendor, a BMS from another, thermal management from a third, and pack integration from a fourth. American Lithium Energy's full stack capability spans the complete energy storage subsystem. From cell-level electrochemistry design through module engineering, pack integration, battery management systems, and thermal control, We can serve as the single accountable organization for the entire energy storage subsystem on your program. What does that mean operationally? Fewer integration interfaces to manage, unified technical documentation across the full stack, one point of contact for any energy storage system question, issue, or requirement change. For program managers who've experienced the cost and schedule impact of interface management between multiple vendors, this is not a minor convenience. It's a program risk reduction tool. Our scale range covers the full spectrum, from watt-hour class microenergy systems for small UAS and munitions applications, up to megawatt-hour class platforms for shipboard or ground-based directed energy systems. No other domestic supplier offers that breadth. And our BMS is designed in concert with our cell characteristics, not sourced from a third party and adapted. Thermal management is integrated at the design stage, not retrofitted. That distinction shows up in system performance, reliability, and certification effort. One of the most strategically significant aspects of American Lithium Energy's technology position is dual-use applicability. The same cell architecture that powers electrified vertical lift also delivers the pulse power backbone required by directed energy and electronic warfare systems. This is not a coincidence of product design, it's a deliberate capability position. For eVTOL platforms, American Lithium Energy provides high power cells for vertical lift and high energy cells for sustained flight. For directed energy weapons, we deliver extreme pulse capability for high energy laser systems. For electronic warfare, sustained power for high power radar platforms. For tactical edge compute and forward deployed systems, reliable distributed power independent of grid infrastructure, the strategic acquisition implication is significant. A program office procuring American Lithium Energy technology for an eVTOL platform is simultaneously investing in a power infrastructure applicable to a much broader range of emerging weapon systems. That commonality across platforms reduces logistics complexity and maximizes return on technology investment. Here's the bottom line: energy storage is becoming a weapon system. The ability to deliver high density, high power energy on demand, reliably, safely from a secure domestic supply chain is as strategically significant as the platforms that energy enables. American Lithium Energy delivers that power backbone. American Lithium Energy's technology portfolio addresses power requirements across all operational domains: air, ground, sea, and space. This multi-domain applicability is a direct result of the fundamental cell technology advantages: ultra-high energy density, extreme power capability, wide temperature operation, and zero-volt technology. Zero-volt technology deserves specific mention. It enables safe battery dormancy for munitions and space systems, applications where a battery may sit in storage for extended periods and then be required to perform immediately and reliably. That capability doesn't exist in conventional commercial cell platforms. For joint force programs and multi-domain operations frameworks, American Lithium Energy is not simply a component vendor for a single platform type. The same technology investment applies across the full breadth of defense electrification requirements. As electrification expands across the joint force, the strategic value of that investment grows with it. American Lithium Energy's domestic manufacturing infrastructure is designed from the ground up for defense production requirements, not adapted from consumer electronic supply chains. That distinction shows up in quality systems, supply chain provenance, and production flexibility. GWH scale U.S. manufacturing capacity, rapid prototyping through full production, AS9100 aligned quality management systems, fully NDAA-compliant materials sourcing. These aren't aspirational capabilities, they're our current production architecture. For defense acquisition professionals, supply chain provenance is a compliance requirement. American Lithium Energy's fully domestic supply chain eliminates the foreign dependency risks that have impacted other battery suppliers operating through international cell manufacturers. Every cell in an American Lithium Energy product is designed, manufactured, and quality certified on U.S. soil. Rapid prototyping capability means we can support early-stage platform development with engineering samples and performance characterization data before committing to production tooling. That reduces the risk and cost of cell selection decisions early in the program lifecycle, when design freedom is highest and change costs are lowest. Key performance numbers: 400 plus watt hours per kilogram target energy density, peak discharge rates from 1C to 80C plus, pulse current capability from 10 to 250 amps plus, and 0-volt technology for safe dormancy in munitions and space applications. That combination in a single domestic supplier does not exist anywhere else. The defense battery market has no shortage of vendors. What it lacks, and what American Lithium Energy uniquely provides, is the combination of ultra-high energy density, extreme power capability, defense-grade safety architecture, and fully domestic production at scale. Let me be direct about the 4 reasons American Lithium Energy represents a different proposition. First, high energy and high power in one platform. American Lithium Energy eliminates the traditional trade-off between energy density and power density. No other domestic supplier delivers both in a single defense-qualified cell architecture. Fewer cell types, simpler pack architectures, reduced integration complexity for systems integrators. Second, safety without compromise. SafeCore and 0-volt technology are engineering decisions embedded in the cell design, not marketing claims. Safety performance is validated against military-relevant abuse conditions, not just commercial certification benchmarks. For deployed platforms, that's the difference between a battery and a trusted weapon system component. Third, scalable US-based manufacturing, GWH scale domestic production, AS9100 aligned quality, fully NDAA-compliant supply chain. American Lithium Energy can scale from engineering samples to full rate production without changing the manufacturing location, supply chain, or quality management framework. Fourth, proven aerospace development experience, cell chemistry optimization, pack thermal analysis, BMS software. American Lithium Energy's technical depth exceeds what any commercial battery reseller can provide, and it translates directly into program risk reduction. Defense electrification is accelerating. Future vertical lift, multi-domain operations, agility prime, unmanned maritime systems, all of them converge on a single dependency. The constraint is no longer vision, it is power. American Lithium Energy works directly with defense prime contractors, program offices, and systems integrators at every stage of platform development, from pre-concept power trade studies and cell technology selection through prototype pack development, certification support, and production delivery. Early engagement maximizes the design freedom available to achieve mission power objectives. If you're evaluating power systems for eVTOL, directed energy, or autonomous platforms, I'd invite you to initiate a technical exchange with American Lithium Energy's defense engineering team. We'll provide cell performance data, application-specific analysis, and program support scoping at no charge. American Lithium Energy. Mission-ready energy storage for electrified air dominance, built in America, engineered for the fight. Visit us at americanlithiumenergy.com. I'm William Hadala, and thank you for watching The Watt Hour.